friends, this is Priyanka. Today we are going to solve a problem on Watt governor with the help of diagram. Watt governor is the simplest form of the centrifugal governor. In this video we are going to use simple basic formulas instead of using complicated formulas. Now first I will read what is the given problem. Calculate the vertical height of Watt governor when it rotates at 60 rpm. Also find the change in vertical height when its speed increases to 61 rpm. So this was the given question. Let us first understand what is the position of the fly balls when the governor is rotating at minimum speed and maximum speed. So here is the diagram. This is the pivoted point, and about this pivoted point there are the fly balls are rotating about this vertical spindle axis. So this pivoted point P and fly ball is connected to this arm, and here the end point is connected to the fly ball is known as the link. Now here when the fly balls are rotating, there is the centrifugal force that is acting in radially outward direction, and fly ball is having mass m, and because of that we have to show here weight will act in vertically downward direction passing through the center of the fly ball. Now we will first consider the equilibrium of this system. That is, we will consider these fly balls are rotating with minimum speed, and minimum speed we will consider n1 is equal to 60 rpm. Then we will take moments of forces about this pivoted point P. Now with the help of compass we will understand this moment. Now this is the pivoted point P, and about which we have to take moment for the centrifugal force as well as weight W. Now when I draw one horizontal line passing through the center of fly ball, then here is the vertical spindle axis, and this horizontal distance from the center of the fly ball, and this is the point of intersection of this horizontal line with this vertical spindle axis, then this horizontal distance is r1. And in the same way, from this point, intersection point passing through the center of fly ball and the spindle axis up to this point P is known as the vertical distance, and it is height h1. Now we will take the moment of force about point P. So we will consider the system when it is rotating at n1, that is at minimum speed. So if I move the compass in the direction of centrifugal force, and here is the center P, then what is the direction? So direction here, if I show in this clockwise direction, and this is the force Fc. Now we have to take the perpendicular distance from this point P. So Fc multiplied by this vertical distance h1. Now again we will take this P as a center and move the compass in the direction of weight, that is in the downward direction. So here we will move the compass in this anti-clockwise direction. So again we have to take this weight W multiplied by the perpendicular distance from this pivoted point P. So here is the distance r1. So W into r1. So both are in opposite direction. So we have to write here in that is on left hand side Fc into h1, which is equal to W into r1. That is on both the sides of this equation. So what is this Fc? That is the centrifugal force. So how we can write this centrifugal force? That is mr omega square. So instead of r we will write here r1. And what is this omega? So if we observe, this omega is nothing but 2 pi n by 60. But here n is equal to n1. So again we will put here the formula. So if we observe here mr1 omega square, that is nothing but Fc into h1, which is equal to, now this weight W is nothing but m into g. So here mg into r1. So this r1 is getting cancelled, m is getting cancelled. So what is the equation? That is omega square h1, which is equal to g. And what is this omega? 2 pi n1 by 60 bracket square into h1, which is equal to g. Now what is the question? That we have to find out this height h1. So if I take here H1 on one side and transfer all the terms to the other side. So here G into 60 square divided by 2 pi n1 square, that is 4 pi square n1 square. So n1 is 60 rpm. So I will take here 60 square, that is 3600. So what is the value here? G is 9.81 into 3600 divided by 4 pi square into 3600. So this 3600 is getting cancelled, and what is the answer? 0.248 meter. So this is the height h1. Now again we will move for the next, that is the speed is getting increased. So as the speed is getting increased, this fly ball will transfer from this position towards this position. So again here centrifugal force is there, weight is there. Now what is this distance? So the line passing through the center of fly ball up to this vertical spindle axis, this horizontal distance is r2, and the vertical distance from this point P up to this point of intersection is known as h2. So instead of r1 we have to write r2, and instead of h1 we have to write h2. So we can use here this formula, that is h1 is equal to G into 60 square divided by 4 pi square n1 square. Now here instead of n1 we have to write n2. So here h2 is equal to, what is the value of G? That is 9.81 into 60 square, that is 3600 divided by 4 pi square into n2 square. So it's 61 square, that is 3721. So what is the value of h2? That is 0.240 meter. But what is the question? The question asked is the change in height. So h1 is 0.248 meter, h2 is 0.240 meter. So what is the change in height? That is h1 minus h2, which is equal to 0.008 meter and which is equal to 8 millimeter. And this is the answer.